Hello, welcome to the video for the 632 ISD project 9 Events of Instruction by me, Leah Gaines. I'll start by explaining to you guys a little bit about the students that I teach. So I teach 8th grade math, and I just teach the regular ed math. I don't teach the students who are struggling, and I don't teach the advanced students. So these are just regular ed 8th grade math students. I teach in a suburban middle school, so the vast majority of our students are white, upper middle class students, but our district includes students who would go to Columbus public schools, so that portion of our district is usually economically disadvantaged students. So there are some students mixed into our school who are economically disadvantaged, and then also that kind of creative districting also includes some students who are ELL, English language learners, but we don't house the students who are struggling the most with learning English. We have the students who are a little further along. There are other schools who have units for ELL that house the students who just got to the country. Many of our students have been with us since sometime in elementary school, so they're a little higher level. So what that means for my class, I do use videos in my class, instructional videos in my classes. So for the ELL students, because we have kind of the higher level students, the modifications that they require for the videos are pretty much things that they can do on their own. So it's important that they stop, pause, rewind videos, rewatch videos all the way through to review homeworks, quizzes, everything. Several of my ELL students rewatch the videos throughout the year to kind of help them review. And then additionally, I write things down on the screen. That's just helpful for all of the students, but especially for the ELL students, it kind of helps them, especially with larger vocabulary words, so that they can follow along and take notes with the videos. And then also for my economically disadvantaged students, I gave out a survey to all my students at the beginning of the school year to find out who has computers and internet access at home and who does not. And so for those students, usually it's the economically disadvantaged students who do not have a computer and or internet access at home. They have a couple of different options. A few of them this past year, their parents were able to get them to a library, so they were able to go to the library to watch the instructional videos as needed. And then for the students who are not able to get to a library, we set it up so that during their study hall period, they could either come to my classroom and use one of the computers to watch the videos, or they could go to the school library during their study hall to watch the videos. So that gives you an idea of the students that I'm working with. And then for the lesson you're about to see, here are the objectives. By the end of the video, the students should be able to explain the difference between a continuous and discrete relationship and analyze a graph to determine if the points should be connected or not. So I used this video early last school year because the students hadn't done well on a quiz. They had somehow missed how to decide between discrete and continuous on a graph. So I made this video to help them review so that they could successfully complete this graphing in class and on the upcoming test. So do you guys remember when I handed back your tests the other day and you reacted like this to your grades?
Good afternoon, sir. Could we interest you in some chocolate?
Chocolate? Did you say chocolate?
Yes, sir. With or without nuts.
Chocolate? Chocolate! Chocolate!
Well, to help you guys out before the big chapter test, the following is a video to help you review discrete versus continuous graphs. So that is the topic on the test where people lost the most points. So hopefully once you're done with the video, you will be able to successfully complete problems like that on the chapter test. So let's begin by talking about the objectives of our lesson today. So by the end of the video, you should be able to, first of all, explain the difference between a continuous and discrete relationship. So the first step is understanding what the difference is between the two relationships, whether or not you see them on a graph. And then secondly, you should be able to analyze a graph to determine if the points should be connected or not. So remember, connected means it's continuous, not connected means discrete. So whether or not you make a graph, so on the test, for example, you may or may not be asked to create a graph, and then you will have to decide, is that a continuous or discrete graph, right, for a line graph. We'll also be doing an assignment in class tomorrow where you'll have to decide if a graph that you make is continuous or discrete. So that'll fulfill the second objective here. Make sure you are taking notes, listening closely during this video so that we can review discrete versus continuous. You will see it on the chapter test, so you're going to want to make sure that you really get it this time. Feel free to watch this video as many times as you like. Feel free to rewind and watch over. Feel free to come to class with questions for me. But again, you're going to want to take notes on this, and I will be checking these tomorrow as part of your homework. Okay? So let's go ahead and get started. So we've heard this word before, and we've talked about it in class. Discrete versus continuous relationships. Okay? So a discrete relationship on a graph will look like this. Okay? Here we go. Discrete graph. It's labeled for you. I'm trying very hard to circle it neatly. There we go. Okay, so this is what a discrete graph looks like. Okay, when you see a discrete graph, the points are not connected. Okay, points are not connected. Maybe you want to pause this and take a quick sketch of a graph where the points are not connected. But that's what a discrete graph will look like. Okay, and then as you can see over here, on a continuous graph, the points are connected. Okay, we're going to talk about in a second what the difference is, but that's the first main thing you need to remember is if I ask you if a relationship is discrete or continuous, if you decide that it's continuous, make sure you connect those points in your graph, okay? If you decide that it's discrete, make sure you do not go ahead and connect those points in your graph, all right? So let's discuss what a discrete relationship is versus a continuous relationship. So when you go to connect the points on a graph, like we've done here in this continuous graph, what you are telling the person who's looking at this graph is that any of the points, okay, that fall on this line, so that if we draw a line, that means there are points here, there are points here, there's points everywhere, okay? If you are filling in the dots with this line, what you are telling the viewer of the graph is, hey, there are points that we haven't plotted because it would take forever to plot every single point here, but we just want you to know that they do exist, so we're going to draw a line to connect those points, okay? So in this example, you'll see that it is number of years after planted and the height of a tree. So this is from that, remember that redwood problem we did in class, okay? So what we're doing is years and height, okay? So we want to connect the points because years go by gradually, and so does height. Height goes up gradually. It's not like, you know, you wake up one morning and you're a foot taller, right? You gradually grow little by little over time. If you measured yourself every single day, you would notice yourself gradually growing tiny piece of a centimeter by tiny piece of a centimeter. So what we're saying, if we say, for example, hey, you know, we're filling in the dots, there's a line here. If we say there's a point right here, then what we're saying is we could be at 2.5 years and find out that, hey, at 2.5 years, that tree is pretty close to 30 feet tall. I'm sorry, pretty close to 15 feet tall. This would be 15 here. Okay? So what we're saying when we connect the points again is that any point in between the points we've already plotted exists. And we want to include that in our graph. Alright? So the opposite of that would be discrete. When we do not connect the points in our graph, what we're saying is that all this space in here is not included in our data set. So, let me just erase. Okay. So, for example, if you look at this graph, we're talking about number of bicycles and the number of wheels. Okay? So it looks like we're saying that one bicycle has 2 wheels, 2 bicycles have 4 wheels, 4 bicycles have 4 bicycles have 8 wheels, 3 bicycles have 6 wheels, so on and so forth. So we do not want to connect the points, because if we were to connect these points, we would be telling people that, hey, any point that falls on this line can exist in this relationship. So you would be telling the people viewing your graph that, hey, this point exists. So it's possible to have a little bit more than 3 wheels on a bicycle that's, 1.75 bicycles is a little over 3 wheels. Well, that doesn't make any sense, right? One bicycle has to have 2 wheels. That's just how it works. We're not talking about unicycles, we're talking about bicycles. So, let's go over that one more time. Discrete. If we decide we're not going to fill in the space between the dots, we're saying that this stuff in between the dots does not exist, that we only want just these points to exist in our relationship. If we're looking at continuous, we're saying, yes, we want to fill in these points between the dots because all the points in between the ones we've plotted exist in the relationship. Now, if you'll notice, there's a bit of a trend here, and that trend is the type of information you're going to find in a continuous graph and the type of information you're going to find in a discrete graph, okay? So in a continuous graph, obviously you're going to see things like height, time, also things like weight, let's see, height, time, weight, any kind of measurement. Okay, so we could say length would probably be a good one. And I mean, certainly when you're talking about over time, right? Time is pretty continuous and gradually changing unit. So now that we've gone over that, let's give ourselves a little quiz here. So let's take a look at these situations right here, okay? What you're going to do is on your paper, go ahead and number your paper 1 through 6. Oops. Go ahead and number your paper 1 through 6. And go ahead and hit pause, wait. Go ahead and number your paper 1 through 6. And what you're going to do is you're going to decide if each of these relationships is continuous or discrete. So a C or a D. You can just write next to your numbers. So what you're going to do is you're going to pause the video, you're going to decide which is discrete and which is continuous, and then you're going to hit play again, and we're going to go over which is which. Okay, so hopefully you've numbered your paper and you've written a C or a D next to each number to kind of give yourself a quiz on a continuous versus a discrete relationship. So let's go over these. Number of suitcases lost by an airline. Okay, so we're just talking about the number of suitcases. So I would call that a discrete relationship because you can't have a fraction of a suitcase, right? Okay, let's talk about, this one says height of corn plants. Remember, when we're talking about measurement, things like height that change gradually, that's going to be a continuous relationship. You're going to want to connect the points there because height changes gradually over time. What about a number of ears of corn produced? I would call that a discrete relationship because you're going to have 1 ear of corn, 2 ears of corn, 3, so on and so forth. But you are not going to have, 1.5 ears of corn produced. Remember, we're talking about number again. Same with the green M&Ms. Number of green M&Ms. That's a discrete relationship. We don't have fractions of M&Ms. Okay, here we go. Time it takes for a car battery to die. Okay. Well, I see time, so that makes me think continuous. When we're talking about a car battery to die, it's slowly losing power over time. So I would certainly call that continuous. You see the time, think about something dying over time, slowly fading away, little by little, that's continuous. And lastly, production of tomatoes by weight. We see the word weight here. Weight is a more gradual unit of measure. So you could have, 1.25 pounds of tomatoes, right? It's not counting the number of tomatoes, we're talking about the weight of them. So that can be in fractional increments, so I would also call that continuous. Alright, so now that you have watched this entire video and diligently taken notes, you are now ready to complete the homework worksheet that reviews discrete versus continuous relationships in graphing. Tomorrow in class, we'll be going over this homework, and at that time you'll be able to ask me any questions you had about the video or about the homework, and hopefully that'll help solidify your understanding a little bit. Then tomorrow in class, I mentioned this before the lesson, tomorrow in class we'll be doing an activity where we'll be collecting data from our classmates and then creating a graph from it. And then when you create that graph, you'll have to decide with your group, is it a discrete or continuous relationship? Should we connect the points or not? And then we'll be taking the chapter test, which I'll be grading. And hopefully on that test, you'll be able to show me your complete mastery of the idea of discrete versus continuous.